Rocket AI in space exploration. Redefining cosmic discoveries. Milky Way introduction. Space exploration has always been at the forefront of human curiosity, but the integration of artificial intelligence, AI, is accelerating our ability to explore and understand the cosmos like never before. Whether it's guiding rovers on Mars, processing massive amounts of telescope data, or assisting in interstellar mission planning, AI is playing a pivotal role in redefining cosmic discoveries. Satellite 1. AI in autonomous spacecraft and rovers. Robot A. AI-powered Mars rovers. AI enhances their ability to analyze geological samples. Machine learning helps identify rock formations that may contain clues about past life on Mars. Optimize scientific missions. AI prioritizes data collection and resource management to maximize the scientific output of each mission. Rocket B. AI in deep space probes. AI is critical for deep space missions where communication delays prevent real-time human intervention. Examples include NASA's OSIRIS-REx mission, which used AI to autonomously navigate and collect samples from asteroid Bennu. ESA's Hera mission, which will employ AI to study asteroid deflection and planetary defense strategies. Telescope 2. AI in astronomical data analysis. Space telescopes and observatories generate staggering amounts of data, requiring AI to process and extract meaningful insights efficiently. Ringed Planet A. Discovering exoplanets. AI is transforming exoplanet discovery by analyzing data from missions like Kepler and TESS, using deep learning to detect subtle changes in starlight that indicate planets orbiting distant stars. Reduce false positives by filtering out anomalies more effectively than traditional methods. Accelerate discoveries, enabling astronomers to confirm exoplanets faster than ever before. Milky Way B. Mapping the universe. AI is enhancing our understanding of the universe by analyzing massive datasets from telescopes like Hubble and James Webb Space Telescope, JWST, classifying galaxies, nebulae, and black holes using deep learning. Processing high-resolution images to detect previously unseen cosmic structures. Identifying dark matter distributions by analyzing gravitational lensing effects. Hammer and Wrench 3. AI in spacecraft operations and maintenance. AI enhances the reliability and longevity of space missions through predictive maintenance and automated support systems. Wrench A. Predictive maintenance for satellites. AI detects early signs of system failures in satellites and space stations, reducing costly malfunctions. The International Space Station, ISS, uses AI-driven diagnostics to monitor onboard systems and schedule repairs proactively. Robot B. AI-assisted robotics in space. Simon, Crew Interactive Mobile Companion, an AI assistant aboard the ISS, helps astronauts with mission data and real-time problem-solving. AI-powered robotic arms are increasingly used for satellite repairs and space station module assembly, reducing reliance on human extravehicular activity, EVA. Alien 4. AI in the search for extraterrestrial life. AI is playing a crucial role in astrobiology, helping scientists sift through immense datasets to find potential signs of life beyond Earth. Satellite Dish A. AI in SETI, search for extraterrestrial intelligence. AI scans radio signals from space, distinguishing potential extraterrestrial transmissions from background noise. Machine learning algorithms detect patterns and anomalies that human researchers might overlook. Globe B. AI and biosignatures in exoplanetary atmospheres. AI assists in analyzing spectral data from exoplanets, looking for biosignatures such as oxygen, methane, and water vapor. Future missions to Europa and Enceladus could deploy AI-driven probes to detect microbial life in subsurface oceans. Full Moon 5. AI's role in future space missions. Building construction. AI in space colonization. Autonomous AI-driven robotics will be essential for building habitats on Mars and the Moon. AI will optimize resource allocation, environmental control, and energy efficiency in space settlements. Rocket B. AI-powered mission planning. AI-enhanced mission simulations will improve risk assessment and decision-making. Self-learning AI systems will adapt to unforeseen challenges in deep space exploration. Sparkle's conclusion. As AI continues to evolve, it will become an essential tool in humanity's quest to explore, understand, and eventually settle space. The fusion of AI and space technology is unlocking new frontiers, bringing us closer to unraveling the mysteries of the universe and answering one of humanity's greatest questions: are we alone in the cosmos?